In this video, I'll show you how to use Geogebra to make graphs and compute statistics for quantitative data. So first thing is we need to have some data. So we'll go back to our other data set, and I'm just going to copy this out of a spreadsheet. Control C, go into Geogebra here and find my first column, first row, and then just paste in the data. And it's going to make the long variable names really cramped, so you can make those wider if you need to. I have a whole lot more data than I need right here, but that is okay. So to do any calculations, we want to select our variable, and then up here there's a little set of purple bars, and that's to do graphs, and then I'll show you how to do statistics later. So we're going to click on the little purple bars where it says one variable analysis, because we have one variable. Click on it, and over here in the other window, we now have a histogram. So what's different about using GeoGebra versus Google Sheets or Excel is that you don't have as much customizability with your axis and titles. So if you need to make a really pretty graph, GeoGebra is not the way to do it. I'd use a bigger, heavier duty program than this. But this is very quick and very nice for getting the job done. So by default, they used bin widths of, it looks like almost 2. Those are pretty ugly, challenging to read, but it looks like it used a span of 9 and then made 5 equal bars. If we go up here to this little line with a dot on it, the little slider, thank you. We can change the width of the bars and see what happens to the story that the data is trying to tell us. So we can adjust it a little bit. Looks like I hit on a bin width of 1. There we go. And we could change it to something else more appropriate. So that's a histogram. If we want to make a different sort of graph, we just go up to this drop-down box and then choose a different type of graph. So we have a box plot that we could graph, and there's our box plot. And it shows you the min. Here's the first quartile, there's the second quartile, the third quartile, and the max. And it doesn't look like there are any outliers. It's also possible that GeoGebra would let you add in outliers. Let's see. Let's add in an outlier. Let's see what happens. There we go. So adding in an outlier, the graph automatically changed. It marked the outlier with an X and then adjusted all the quartiles accordingly. If we want to make another graph, let's go back out of box plot. Again, not very good labels. If we want to make a dot plot, here we go. So each row here represents one more of the frequency. So for 0, we used a variable, how many cars have you owned in your lifetime? We had 1, 2, 3, 4 students who said they owned 0 cars. And then if we want to read the graph a little bit better, we can try to zoom out. We can use the pluses and minuses. There's the 50. So one person has owned 50 cars in their lifetime. Maybe they own a car shop. That's possible. And if we want to look at other forms of the data, so stem and leaf plot. So we have the stems. Let's see, here in the key 3/1 means 3.1. So it looks like we have 1.0, 1.0, 1.0. We have 3 students who have owned 1 car in their lifetime. And then here at 2, so remember this is 2.0, we have 5 students who've owned 2 cars in their lifetime. And then if there's any outliers, they're often marked with this high to say that they're so far off the charts, because otherwise our stems would need to go all the way to 50, which would be a very long graph for that one little outlier. Kind of a lot of wasted space. Okay, so I just clicked on this button right here. What happens to our graph as we're changing pluses and minuses here? Looks like we can expand our graph. So it is a very big graph now with lots of extra detail that we don't need. Here's back to 0, going back to our key And then, here's changing our key. 3/1 means 31. So that's nice if we have a bigger data set, but when our data set is so small and compact, we want to use this 0 option. It gives us a nice spread, not too much detail, not too little detail. All right, so those are the graphs that you might want to make with just one variable: the histogram, the dot plot, the stem and leaf plot. The more data you have, the more you have to discriminate which of these charts is more appropriate or not. So next, let's do some calculations. We have our data set already. We can click over here on the, looks like an E, but it's the capital sigma X. So this is going to do some statistics. And then you can see the little pop-up there. It says show statistics. I click on it and automatically I get statistics, and I'm going to run through what all these statistics are. So N, that's your sample size. We had 21 because I'm including the outlier. Then it computes the mean. So the mean was 5.2. That was with the outlier. If I want to remove that outlier, I can. Let's see. Go back to highlighting my data. Let's see what happens. Oh, looks like it's pretty unhappy. There we go. Nope, still unhappy. So that was what I get for playing around. I'm highlighting my data again or highlighting my column. I can go back to one variable analysis. There we go. So back to the statistics. I do find that Geogebra does tend to have a whole lot of extra windows that you don't really need. And so if you get a little lost, just refresh the page. All right, so the statistics, we have the sample size, we have the mean, and then here is sigma, so that's a population standard deviation. If we don't have a population, then just ignore this. If we have a sample, which in this case we do, here's our sample standard deviation of 2.9, you could say 2.9 cars on average is the difference between the data and the mean. And then below this, we have sigma x, which just means add up all the data. And then below that is sigma x squared, which means square all the data and then add it all up. These two things right here, sigma x and sigma x squared, we're probably never going to use in our class, but there is a formula for the standard deviation which does use those calculations. And they're easy to work by hand, which is why they're still kind of there. But when we're using the computer, it doesn't really make a difference. We don't need that sort of information. The bottom 5 numbers here are the 5-number summary. So the minimum, the smallest number of the data set is 0 cars, first quartile is 1, median is 2, third quartile is 5.5. You'll notice that was just a little different than what Google Sheets gave, and that's because there is no one definition for a quartile. And similarly, there's no one definition for the median. So you might find that quartiles computed on Excel, Google Sheets, Geogebra, your computer, or working by hand might be a little bit different, and that's okay. The person grading your work is going to know that the answers may vary, and they'll either tell you which way to do the work or be generous and accept multiple answers. And then lastly, there's an X. So here we have Geogebra for making graphs and doing statistics. And I forgot to mention that you'll want to go to the website www.geogebra.org/classic #spreadsheet. You can also get rid of that spreadsheet part and just say classic, and it will get you to a new spreadsheet, and then you can choose which, a whole new setup here, and you can choose what you need to go to. So I can click on spreadsheet, and here I